Hi guys, so this is the second video on tangents and normals under Math SL differentiation. We shall continue with questions that require us to analyze the slopes. There was a previous video tackling the same topic. The questions in this video are slightly more indirect, so they're slightly more challenging. I shall begin with question 1 shortly. So the first question came in paper 1, November 2001, time zone 1, question number 7. Kindly take a minute and pause the video, attempt to solve, and my answer shall follow through shortly. So in question A, we are required to find f dash given this function f, where k is a constant and unknown that we do not know. So take a look at the answer. So if f of x equals k sine x plus 3x, then we shall differentiate to get k cosine x plus 3. This is very straightforward differentiation. Now in question B, we are told that when x equals pi over 3, the gradient is 8. So we translate this into the equation f dash of pi over 3 equals 8. The gradient of the curve at x equals pi over 3 is 8. So how do we use this? How do we use this information? We simply substitute x for pi over 3 in the red equation and we equate to 8. So instead of k cosine x plus 3, we're going to get k cosine pi over 3 plus 3. So this is the gradient at x equals pi over 3. What is the value of the gradient? 8. So we equate this to 8. Cosine pi over 3 or cosine 60 degrees is equal to half. So we simplify and we solve a very simple algebraic equation, getting the value of k, which is equal to 10. So pause the video, copy this down if you will, and I shall begin the second question shortly. So the second question came in paper 1, May 2010, time zone 2, question number 5. Kindly pause the video, attempt to solve, and my answer shall follow through shortly. So we are told that f of x equals kx power 4, and we are given that point P that has coordinates 1 and k lies on the curve of f, so it follows the curve of f, and at P the normal to the curve is parallel to y equals negative 1 over 8x. So the first keyword that should draw my attention in this problem is the word parallel. We know that parallel lines have equal slopes. So the normal to the curve shall have the same slope as this line. Hence, the slope of the normal of the curve at P is negative 1 over 8. So take a look at the answer. So I begin by making the deduction that the slope of the normal at P is equal to negative 1 over 8. Now, I need to find the value of k, so I need to find information about the curve itself, so it will help me a lot to actually use the slope of the tangent. And I can get that very simply by transforming the slope of the normal, switching the sign and flipping. So 8 was in the denominator, it goes to the numerator, and it was negative, so it becomes positive. So since we know that the slope of the tangent at P is 8, we know that the slope of the tangent at x equals 1, which is the x coordinate of P, is 8. So if the slope at x equals 1 is 8, that means that f dash of 1 equals 8. This is the concept that you need to understand. That if I know the slope of the tangent at a point, I translate that into f dash of x, where x is the x coordinate of the point, equals the number or the value of the slope. Now, if I know that f dash of 1 is equal to 8, I need to find an equation for f dash of 1. So I need to get f dash of x. And so let me give you a small hint. Of course, if we have an equation f of x and we are talking about the normal to the curve, then we are talking about slopes. So I'm definitely going to differentiate. So even if you don't quite understand what the question wants from you, you know that differentiating is a part of the answer. So you just do that. Because sometimes the wording of the question is confusing. So use your keywords to find the appropriate math processes that you need to implement in the question. Normal, then I'm going to differentiate, find the slope, find the tangent, the things that I associate with the word normal to the curve. So anyway, we differentiated this function kx power 4. We got 4kx power 3. And then since we got f dash of x, we can easily get f dash of 1 by replacing x with 1. So we get 4k1 to the power of 3, and that is equal to 8. And this is an algebraic equation, a simple algebraic equation, and we solve to get that k equals 2. So take a minute, copy this down if you will, and I shall begin question 3 shortly. So question 3 came in paper 2, November 2009, question number 5. Kindly take a minute to pause the video, attempt to solve, and my answer shall follow through shortly. So again, in this question we are given the equation of f of x, but in terms of unknowns. So instead of k, we have p and q. We have two unknowns that express the function f of x. But we have some information, and we are required to find the values of the unknowns. Kind of similar to the last problem. Kind of. So what is the information that we have? We know that the point a, 1, 3 lies on the curve. This tells me that when x is 1, f of x is 3. Or in other words, f of 1 equals 3. And this shall help me solve the problem. And we know that the tangent to the curve at A has gradient 8. Tangent to the curve at A, so tangent to the curve at x equals 1, because A has an x coordinate of 1. So at x equals 1, the tangent has a gradient of 8. Hence, f dash of 1 equals 8. We are going to use this information to solve. So here is the answer. So the first given, which is that the point a, 1, 3 lies on the curve, is translated into 3 instead of f of x and 1 instead of x in the given equation. So when x is 1, y or f of x is 3. Hence, we use this information to form our first equation in P and Q. 3 equals P plus Q. And the second given, which we just explained, tells me that f dash of 1 equals 8. The tangent to the curve at A, where x equals 1, is 8. Or has a slope of 8. Hence, f dash of 1 equals 8. So I find f dash of x by differentiating this function, and the derivative is 2px plus q. Next, I remove x and put 1, and I remove f dash and put 8. And I get a second equation in P and Q. Finally, I solve the two equations I obtained simultaneously. You can use the GDC, of course, because this is a paper 2 question, but this is also a very simple algebraic problem to solve. You just isolate one of the variables like I did here. I isolated the q in the first equation, so q equals 3 minus p, and I substituted 3 minus p for q in the second equation, so I have 2p plus 3 minus p equals 8, as you can see in the red equation right there. I simplified and I found the p. Then I plugged the p into this equation, q equals 3 minus p, to get the q. So the value of p is 5 and the value of q is negative 2. So take a minute, copy this down, and I hope you have found this useful. This concludes our second video on tangents and normals.